All right, picture a futuristic sports car engine. That's kind of what we're looking at today. Welcome to this explainer. Today, we're popping the hood on Solana. You've probably heard about it. Launched in 2020 by Anatoly Yakovenko, it's famous for massive throughput, ultra-low fees, and being the go-to spot for DeFi, NFTs, and yeah, those rapid-fire meme coins. But how exactly does this 65,000 transactions per second engine actually work? Let's dive in. So, here's our roadmap for today. We'll start with the need for speed. Break down how proof of history actually works. Get into Solanic tokenomics. Do a fair comparison of Solana versus Ethereum. And finally, look at getting started with Phantom. All right, part 1, the need for speed, solving the blockchain bottleneck. Look, we all know legacy networks like Bitcoin and Ethereum are super secure, right? But man, they can be incredibly slow. It's literally like trying to walk through a crowded room where everyone has to stop and agree on the exact time before anyone can take a single step. Solana totally shatters that bottleneck because it can process thousands of transactions per second. You aren't priced out by crazy congestion fees. I mean, instead of paying $20 for a simple transfer, you're paying a fraction of a penny, like $0.00025. That right there, that opens up a whole new world for microtransactions and high-frequency trading that older chains just literally cannot handle. Moving on to Section 2, Proof of History Explained, the Synchronized Symphony. So back in 2020, founder Anatoly Yakovenko had this massive lightbulb moment. He realized, hey, if we inject a trustless clock directly into a blockchain, the nodes wouldn't have to constantly pause and check in with each other. And that clock, that's proof of history. Now keep in mind, this isn't a consensus mechanism like proof of work. Instead, it's a super clever cryptographic way to mathematically prove that a specific amount of time has passed between two events. It basically timestamps transactions before they even enter the whole consensus process. You can really see how this plays out if you look at the flow here. You've got this single leader node, and its job is to take in user messages and sequence them first. But using that proof of history generator we just talked about, it organizes everything super efficiently and then passes it right down the line to the verifier nodes. And since the timeline of events is already mathematically locked in and proven, well, those verifiers can confirm the blocks incredibly fast. We're talking sub-second finality times here. Think of it kind of like a relentless digital metronome. You start with a random value, run a SHA-256 hash on it, take that output, hash it again, and just keep recording the count. Because you can't predict this function and it has to run sequentially on a single core, it inherently tracks the real-time passage of time. When you send a transaction, your data gets scooped up and appended right into that ongoing sequence. So any future hashes are forever altered by your insertion, which creates this totally immutable, verifiable timestamp. It's pretty genius. Now, if Ethereum is like waiting in a single file line at the DMV, Solana acts way more like a modern GPU loaded with thousands of cores. You see, most blockchains are single-threaded, meaning only one smart contract can modify the state at a time. Everyone else just has to wait. But on Solana, transactions explicitly declare ahead of time exactly which accounts they're going to read and write. Because the system knows exactly what data is going to be touched, its C-level execution environment can sort and run thousands of non-overlapping smart contracts simultaneously, in parallel. It's an absolute game changer for computing architecture. All right, Section 3, Understanding SOL Tokenomics, Fueling the Engine. A high-performance engine obviously needs optimized fuel, right? Running a Solana validator is no joke. It requires some seriously heavy, expensive hardware, not to mention significant voting costs. You're looking at roughly 2 to 3 SOL per epoch just for that. So, to make it worth their while, validators earn their keep through 3 distinct revenue streams: inflation commission from network issuance, base block rewards plus priority fees, and of course, MEV tips, which they get from reordering transactions. But wait, you might be wondering, if the SOL supply has literally no hard cap, why doesn't inflation just completely ruin its value? It's a totally fair question, especially since the initial inflation rate kicked off at a pretty high 8%. Now, unlike Bitcoin with its strict hard cap of 21 million, Solana's total supply is uncapped. This is by design to make sure there's a continuous incentive for those validators. But don't panic, this doesn't mean hyperinflation. The network actually uses a very specific mathematically deterministic inflation schedule. So while that inflation rate drops by 15% every single year until it settles at a fixed 1.5%, there's also a massive counterweight. 50% of every single transaction fee is permanently burned to create scarcity, destroyed, gone forever. Every time you make a transaction, half the fee pays the validator and the other half goes up in smoke. During times of massive network activity, this high burn rate actively fights back against the inflation schedule, creating this really elegant dynamic balance between rewarding the folks securing the network and protecting the token's actual value. Let's jump into Section 4, Solana versus Ethereum, an impartial analysis. In blockchain design, there really is no free lunch. You are always playing this tug of war between speed, security, and decentralization. And looking at the numbers here, the fundamental trade-off is pretty clear. Ethereum prioritizes maximum, battle-tested security, relying on an absolutely massive network of over 700,000 validators. Solana, on the other hand, trades a bit of that extreme decentralization to achieve those blistering, cost-effective speeds, using around 1,500 highly equipped validators. Basically, Ethereum is the ultra-secure heavy-duty bank vault, and Solana is the lightning-fast, high-frequency trading floor. Okay, final section, number 5. Getting started with Phantom, your key to the ecosystem. Now that we've totally geeked out on how the engine works, let's actually grab the keys. If you want to jump into this high-speed environment, you're going to need a gateway, and the Phantom wallet is generally the go-to here. Getting set up is super straightforward, but please pay absolute attention to the security side of this. When you create this wallet, you aren't just making a profile on some tech company's server. You are generating raw cryptographic keys. So the most critical step by far is number 3, securely recording your 12 to 24-word seed phrase. I really have to stress this point, guys. There is no customer service line in crypto. If you lose the seed phrase, you lose your assets permanently. As one of our sources pointed out, and it's a great rule of thumb, if a hacker gets into your cloud drive and finds a screenshot of this phrase, they will drain your wallet instantly. No refunds. Phantom can't reset your password. You have to write it down on physical paper, put it in a safe, and keep it offline. But once you're inside and secure, Phantom is awesome. It gives you direct access to early token launches, NFT marketplaces, the whole shebang. You can actually buy salt right there in the app using Cash or Apple Pay, or just transfer some over from a centralized exchange. From there, you can connect to decentralized exchanges for ultra-low slippage swaps, or hit up marketplaces like Magic Eden. One pro tip, though. When you're messing around with brand new or unverified apps, always use a burner account within Phantom. Just fund a secondary wallet with a couple of bucks. That way, if a sketchy contract tricks you, your main stash is completely insulated and safe. So what does this all mean for the big picture? As major upgrades like FireDancer, which is this totally independent validator client currently in the works, aim to virtually eliminate the network outages Solana saw in its early days, we really have to wonder, will this relentless bet on raw speed and parallel processing define the future of the internet's financial layer? The tech is breathtakingly ambitious, basically saying that a frictionless, consumer-grade experience matters more than traditional blockchain dogma. So here's the question I'll leave you with. As these networks mature, will the world ultimately choose the slow and steady, battle-tested security of a massively distributed network? Or will the sheer convenience and face-melting speed of parallel processing become the undisputed global standard? Thanks for exploring this one with us today.